Hi, question number 3. We have x squared minus 2 plus p in brackets times x plus 7 plus p in brackets is equal to 0 has roots that differ by 1. Find the value of p given that p is greater than 0. Okay, to do a question like this, I'm going to let the roots be alpha, and therefore we have x is equal to alpha, and the second root is going to be x is equal to, because the roots differ by 1, so alpha plus 1. And therefore, if we take this minus that, we're going to get 1 as the difference between the roots. So now from here, it can be said that x minus alpha into x minus alpha, then minus 1 is equal to 0. And so we have to expand this. So expanding this, we're going to get x squared minus alpha x minus alpha x minus alpha to the square plus alpha is equal to 0. And so if we have to simplify this, I've got x squared minus alpha x is minus 2 alpha x, then minus x, okay, and then minus alpha square plus alpha is equal to 0. Now we can also try and simplify this part here, and if we were to do so, I'm going to get minus 2 alpha plus 1, because there's 1 here, so 2 alpha plus 1, and the minus goes outside, and if you distribute inside, then everything becomes minus again. So into x minus, so we have then alpha square plus alpha is equal to 0. Now, so this should have been plus alpha square, because, yeah, minus alpha times minus alpha is plus alpha square. So we have a plus here and a plus here. Right, so there we go. And this equation here can be compared to that equation there. So we have the coefficient of x being 2 plus p, and the coefficient of x is 2 alpha plus 1. So 2 plus p is equal to 2 alpha plus 1. And if I were to simplify this, I'm going to get p is equal to 2 alpha plus 1 minus 2. So p is going to be equal to 2 alpha minus 1. Now, since p is equal to 2 alpha minus 1, I can compare again and see alpha square, okay, plus alpha is equal to 7 plus p. So we also have alpha square plus alpha by comparison is equal to 7 plus p. So we're comparing the constants of the equation. So then I basically get, so 7 plus p is equal to all of that. And because we know that p is equal to 2 alpha minus 1, so the p can be substituted for 2 alpha minus 1. So I've got alpha square plus alpha, okay, is equal to 7 plus 2 alpha minus 1. Now what I'm going to do is I'm going to try and simplify this. So we've got alpha square, okay, the alpha minus 2 alpha on this side is going to become minus alpha. And then I've got 7 minus 1 is 6, and 6 can be brought on the other side. It's got minus 6 equal to 0. Immediately I can solve this equation, and I get alpha. And so I can say 3 times 2, because there's a minus here, so minus 3 plus 2 is negative 1. So now we have an equation, a quadratic equation that's been solved. So I got alpha is equal to negative 2 and alpha is equal to 3. We are told that p is greater than 0, so alpha cannot be that negative value here, because we know that p is equal to 2 alpha minus 1. So we're going to say then p, therefore, p is equal to 2 times alpha. Alpha is 3, so 2 times 3 minus 1, which then becomes 6 minus 1. So that's my value of p, leading to p is equal to 5. And so, of course, this one here is rejected, because if you take this, the value of p would then be less than 0. But in the question, it's clearly stated that the value of p is greater than 0. So here we are, and this is how we do a question like this, which is based on roots of polynomials equations for further maths. Take care.